So I work for Red Hat in the UK, but I'm actually from Canada, so I'm sort of a visitor to the UK. And of course, one of the things that really impressed me when I moved to the UK was the bagpipes. So who's heard bagpipes? And who's heard someone try to give a talk accompanied by bagpipes in the background? See? We're going to have a bit of that sort of UK experience, just with an alarm system instead of bagpipes. But they actually sound incredibly similar. So they could have saved a whole bunch of trouble inventing bagpipes and just used the alarm. So I think the background is really appropriate because I'm going to be talking about all the things that go wrong, the chaos and the mayhem. Not about buildings, about clouds, but it's the same idea. I feel incredibly lucky to be a developer. Hands up who feels lucky to be a developer except at this particular moment. Yeah, I mean, I think we have such fun jobs. We get to do all this problem solving except of fire alarms. And I think as well, because I've been a developer for 20 years and the changes that I've seen in that time have been almost all good. So many things are easier now, and so many things have less friction than they used to, and there's just less hard work than they used to. So it used to be I had to have about 4 big servers, and I'd sort of have them under my desk and on my desk, and then I had a second desk to store them, and I had to keep re-imaging the operating system on them, and I had to keep reinstalling them, and it was all just a bit of a nuisance. Whereas now, with the magic of the cloud, it's a one-button click, and I provision the machine, and then it goes away when I don't want it. But of course, the cloud in general makes everything more awesome, and it saves a lot of drudgery. But that doesn't mean that clouds don't come with their own hazards. A lot of us and a lot of organizations, when they start using the cloud, find they get electrocuted. And so the expectations for us as developers have changed a lot since even 5 years ago, 10 years ago. And there's a whole bunch of things that you need to be able to do in 2022 that you didn't really need to think about as part of your job. Because it's 2022, the first one of those is hand washing. I sometimes think hand washing is now a full-time job just to try and keep everything washed. And of course, the main job for most of us is app development. But we can't do just app development anymore. We need to have some understanding of what happens to those apps when they leave our laptop and go out into the world. So we really need to be working on the ops side as well. I think that's really positive, but it is an extra cognitive load for us. And of course, when you combine that app dev and the ops side, then that is DevOps, which we should have all been doing for some time, but I think a lot of us are still figuring out quite how to do it. And the problem with DevOps as an idea is there is no security in there. And quite rightly, I think a lot of people said, shouldn't we be thinking about security earlier in the developer cycle as well, rather than thinking about security once we've had a breach and it's really embarrassing? So now a lot of us talk about DevSecOps. And then, of course, the business said, wait a minute, don't I get to a few letters in that as well? So then you get Biz Dev Sec Ops, and then you get Design Ops. And I won't go through all of them because there's just too many to list. But there is that one that I want to call out, which is maybe one that not a lot of us are thinking about, but I think we should be. And that's FinOps. So that's thinking about, basically, how much the stuff we're doing costs and how we can try and get that information, which is really important. The reason we have so many new things to learn is because the world is changing to accommodate the cloud, and a whole bunch of new technologies are coming in, so we need to be thinking about tracing differently, packaging differently, performance differently, modularity is different. And so it's a lot. I don't want to talk about everything that's different in the cloud, because that would be a very long talk, but I just want to cover some of the few things that are maybe not obvious and that are maybe still catching us by surprise. So it's totally obvious that technology changes fast. That's kind of the point of technology. You don't need me to stand up here on this big stage and say, did you know technology changes fast? Because that's something that you see every day. That's something that you're helping to drive. But even though we all know technology changes fast, and even though we've had the cloud for a good 10 years, or maybe, depending how you count, probably even more, we've had microservices for 10 years, it is still taking us a while to catch up to the cloud. And there's still so many things that we're not quite doing right for the cloud, and we're still doing it like we were operating in the pre-cloud era, even though we've had the cloud for so long. I don't want this talk to be completely miserable, so I want to start with a fairly happy story. I think this is something that we had a problem with, and now we're getting much, much more on top of it. So we used to talk about tracing. Now we talk about observability because it's 2022. Sometimes we use the word correctly. Sometimes we don't use the word correctly, but that's the word we use. And we needed to do something differently in the cloud, because the old way of debugging a system when it went wrong was you had your hardware, and you had your little application running on the hardware, and then you had the logs. In the cloud, your application's not running on the physical hardware, it's running on a container. And it is quite likely to, at various points, stop running on the original container and start running on a different container. So what happens to those logs? If we just leave the logs on the box, when the container disappears, the logs disappear. And I know I certainly had this experience when I was first starting to work in the cloud. I was incredibly frustrated because something would go wrong, and I'd say, okay, no problem, I'll just log into the box and get where is the box? There is no box, there is no logs. I have no way of knowing what happened to this thing. It's a mystery forever. So of course you have to take your logs and send them somewhere that is not the box where your application is running if you're going to have any hope of diagnosing problems. But then of course we have a second problem, because we don't usually have just one application on one server running in the cloud. We usually have microservices. So we have a whole bunch of applications. And that's probably a good thing. But how on earth do we make sense of all of those logs when a single transaction, a single thing, could have its data smeared across many, many logs, some of which are probably still in the box, some of which have been transferred somewhere else? It just all gets a bit complicated. So we need to be, first of all, getting them all off the box, but then having some sort of tooling support as well to help us try and understand what's the correlation between these events. We're in pretty good shape here, I think. We used to have open tracing. That's now deprecated in favor of open telemetry. Both very good solutions. I think both are solving our problem. And the really lovely thing that I like to see about those as well is the clues in the name, but they're so open. So we do have this industry standardization so that no matter what provider you're using, they almost certainly support open telemetry. And so then you get that interop. So that's the good news. Observability is fixed. Well, sort of fixed. What I sometimes find is when I talk about this, hands up who has implemented observability in their stack. There's maybe a quarter. Hands up who has really good intentions about implementing observability in their stack. Yeah, a few more hands. What I usually find is most of us know what we should be doing, and we feel quite guilty that we're not doing it, but we haven't actually fully put in proper observability. The good news is we only need our first production incident to get proper observability right to the top of the backlog, and then we will have it sorted out. Another thing that is really different in the cloud is performance, and particularly like how we think about performance. What do we expect from our applications? Because it used to be that we would start an application and we would leave it running for 6 months, and we wanted it to process as many transactions as possible. It was on physical hardware, so we didn't really care how much of that hardware it used. We had paid for the hardware. It was dedicated hardware. But of course now, memory footprint is money. You can see the direct correlation between how hungry your application is for resources and your cloud bill. And you can see as well that direct correlation between how angry your users are with you in a load spike and your startup time. So these things that we were able to ignore before, we now need to be looking at. And some of the things that we used to have to pay a lot of attention to, we can kind of ignore. Another aspect of the performance changes is that it used to be, I used to work on WebSphere. We worked so hard to make it dynamic. You could have it running for 6 months and you could completely change the configuration. You could completely change how it behaved. You could dynamically swap modules in and out and capabilities so that you would have a completely different WebSphere at the end of the 6 months than you did at the beginning. But now, almost all applications run in containers, and containers are immutable. You don't want to be dynamically reconfiguring your server on the fly in the cloud, because you just want to run a new build and have a new instance fire up to the cloud instead, because that way you have the auditability, you have the reproducibility, you have all of these good things. So all of that dynamism is now kind of pointless, but a lot of it is still in the code bases of these frameworks. So of course, what's changed now is it used to be that ahead-of-time compilation was a terrible idea because it fought that dynamism. But now, because we don't really need that dynamism, ahead-of-time compilation is all of a sudden a good idea. I talked about this yesterday as well, that we see this shift where the requirements change, and all of a sudden that enables an old idea to become a new idea that's a good idea. Because our performance requirements are different, performance optimization also becomes different. And we see a whole bunch of new problems, and we see a whole bunch of things that all of a sudden are biting us that we didn't expect to. I heard a story from Martin Verberg of Microsoft, and they were debugging a performance problem with Java. And they couldn't figure out, like every request had this horrible latency, and they couldn't figure out what was going on. And then they eventually realized they were doing, full-on proper microservices. So they had 100 microservices chained together to service a request. So already you're going to have a bit of a latency problem just from having 100 microservices chained together. But it was worse than that. Because they were all Java microservices, every time one of them would do a garbage collection, that would slow down the whole chain. So it wasn't that a small percentage of requests hit a garbage collection and were unhappy. Pretty much every single request hit a garbage collection and wasn't happy. So they needed to think about how they structured the application in order to work around this problem. We see other weird behaviors of Java in the cloud. The authors of the JVM have, for a really long time, been trying to make it so that you don't have to tune the JVM yourself. It should just figure out what you want and do the right thing. Usually, it does a pretty good job. In particular, almost always, the default configuration of the JVM will be better than that string that you found on Stack Overflow that you cut and pasted into your application when you looked up how should I tune my JVM, because you get all of this sort of weird antique folk knowledge and weird parameters that now actually are harmful, but because the internet has a really long memory, they're still out there. But sometimes the ergonomics of the JVM do get it wrong. And in particular, the ergonomics of the JVM, I think, haven't quite caught up to the world of cloud and containers yet. There was a problem about 4 years ago that is now fixed, but it was a ridiculous problem where the JVM and Docker were using different techniques to figure out how much memory was available. And so the JVM thought it had more memory than Docker thought it had. And so the JVM would allocate that memory, and Docker would say, whoa, 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 hang on there, buddy. You've just tried to take memory that's not yours. You are a very bad container, and that is the end of your life as a container. And so Docker would kill your JVM, even though, as far as your JVM was concerned, it hadn't done anything wrong. It was told it had this memory, so it took the memory. That is now all fixed, but we do have some more subtle problems that won't crash your application, but will make it run slowly. So my colleague Ben Evans, he wrote this article, Best Practices for Java in Single Core Containers. And what he'd done is he'd basically gone through and read the source code of the JVM to figure out what was going on. Because the JVM, one of the starting points for its ergonomics is it has this idea of you might be a server or you might be a client. And I think that kind of doesn't make sense in 2022, but it's still there. But then the question is, okay, I am writing a server. I want to run in server mode. But what is a server? How does it figure out what a server is? I wouldn't be able to tell you that off the top of my head, but when Ben looked in the source code, what he found is the answer was in code. And this is the answer. You are a server if you have more than 2 physical CPUs and more than 2 gigabytes of memory. So how many of you provision instances smaller than this? A few, right? And that's at the, if you sort of look through like the AWS catalog, there's a whole bunch of instances that are smaller than this. And then once you imagine that maybe you're running something like Kubernetes, and so your virtual machine that is maybe smaller than this has then been subdivided further into containers, like a lot of containers run with less than 2 CPUs. That's the beauty of the containers is you can run millions of them and they're really tiny. But the problem is your JVM says, oh, you're not a server. I'm going to behave really differently. So this is a graph of the garbage collection pauses. And so let me get it right. Yep, so the blue line is when you are running with 1 CPU. And the orangey line is when you are running with 2 CPUs. So obviously you're going to get a little bit of different behavior because it's got more compute power. But the thing to notice here is that the pauses are about 10 times bigger when you have 1 CPU. And I don't think anybody ever said, I'm going to run on a really small instance to save money, but please could you make my garbage collection pauses 10 times as long? So this is completely unhelpful behavior. So the moral of the story there is don't shrink your containers too much, or your JVM may start making very bad decisions. Now, if you've been paying attention, you'll notice that about 10 minutes ago, I said, because of the cloud, you want to run in really small instances because time is money, startup is money, footprint is money. And then I just said, don't run in really small instances because your JVM will behave really weirdly. I know those totally contradict each other, and I've just given you the world's most useless advice because I've given you 2 contradictory sets of advice. This is why the talk is called Cloud Chaos, because some of this, it's just really hard, even in 2022, even though we've been doing this for so long, to figure out what the right thing to do is. And I think things probably get worse as well. Because one of the problems that we have with cloud instances that we didn't really have with physical instances is management. And by this, I don't mean our bosses. I mean the actual management of the hardware, keeping track of it. It used to be we could keep track of it because it was sat in front of us. But the beauty of the cloud is it makes it so easy to provision hardware. It's just one button. and you have an instance. But of course, the cloud is just someone else's data center. So that one button press that gave you an instance, you had to put in your credit card first. And so that instance is not free. Someone is paying for it, probably your company. And that one push that gave you the instance, you may have been doing something really useful, but you may have just been trying something out and forget. So sometimes it's useless. And of course, that one push turns the computer on. It doesn't turn the computer off. You have to remember to do that. So we have this problem now with the cloud. And when I was first learning Kubernetes, I did what anybody learning something would do, which is I tried it out. So I created a Kubernetes cluster. But unfortunately, I had too much work in progress at the time. And so after creating the cluster, I got pulled away to something else. And so I forgot that Kubernetes cluster that was doing nothing for 2 months. And it was a fairly well-spec'd Kubernetes cluster. So it was £1,000 a month for this cluster that I just created and then forgotten about. So that was a slightly awkward conversation with my boss, which means actually management. When I said management, your boss wasn't the problem, it was the management of the hardware. If you get it really wrong, the management of the hardware is the problem, and then your own management become the problem too, because they're looking at you going, why do we have this enormous cloud bill? What do you mean you just provisioned it and forgot it? And of course, often what happens to solve this problem is we get much more controls. So you can't just push the button to provision it. You have to do a spreadsheet. You have to do a requisition request. You have to get 6 layers of approval. And then all of a sudden, the cloud is actually behaving just like it was when it was physical hardware. And even after you've done all of those approvals, those make it harder to get the hardware. But they still don't help you turn it off. So then you have hardware that was really hard to get that now isn't being used, that still stood up. And so these servers that we create and then forget about are called zombie servers. So does anybody want to have a guess? Let's see how bad the problem of zombies is. So hands up if you think 1% of servers are zombies. No, okay. So you all aren't paying attention. Hands down if you think 1% of servers are zombies. Excellent. Hands down if you think 5% of servers are zombies. Okay, now I've confused myself, so I don't know if the people who are putting their hands up. The moral of the story is don't try and outsmart the audience. It doesn't work. So I won't try and do any more questions because it will just end in chaos. I'll jump to the answer. You'll all be really grateful. The answer is 25% of computers are estimated to be zombies. I saw another survey, and they'd sliced it slightly differently, but they reckoned that there was $26 billion worth of public cloud spend that was just on servers that weren't doing anything at all. And when they sort of tried to figure out, like, why was this happening? The best guess they could come up with was perhaps someone forgot to turn them off, which is just, it would be funny, except you know that it's true because you probably have done it too. I mean, even like I've been talking about this for a while, and last month I wanted to get Quarkus building with GitHub Actions on M1. And so I went to Mac Stadium and I provisioned an instance, and then I had too much work in progress. And so that instance sat for 2 months until I actually got the M1 builds going. And it was only like 150 euros a month or something. It wasn't 1,000 euros. But all the time I was like, this is so dumb. I should go deprovision that. But it seemed like too much work to deprovision it when I knew, I kept sort of saying, maybe tomorrow is going to be the day I'm going to go back and look at that M1 build. And this is how we end up with $26 billion worth of waste. So this problem has led to a new category, which is FinOps. So FinOps is basically real-time financial information, trying to bring some of those techniques that we're all used to the financial world. But basically, the use of it is figuring out who in your company forgot to turn off their cloud. Because these things can have really serious consequences. There's a whole little genre now of stories of internet cost disasters. So there was a company, they were a little startup, and they pushed something to Firebase on a Friday afternoon that they thought wasn't going to do anything, and they thought they were in the free tier. And they got into work on Monday morning, and they found they had a $72,000 bill, which was pretty much the whole runway for their startup. So that was awkward for them. And this can happen to really experienced professionals as well. How many of you use Have I Been Owned by Troy Hunt? Yeah, it's such a good resource, right? And so that resource, you can type in your name, your email address, and it will tell you whether those passwords appear on the dark web in the databases of leaked passwords. And so, of course, there's quite a lot of data involved in that and hosting costs, and so he has everything quite neatly cached. And he had this problem, though, because he had these sort of he has to pay to host it. So he had these modest hosting costs. And then over Christmas, when he was distracted by other things and not looking closely, his hosting costs just all of a sudden went dunk, 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 dunk. And he only noticed it at the far right point of the graph. And by the time he noticed it, he had $11,000 worth of hosting costs for this personal site. And so when he tried to look into it to figure out why did this happen, it turned out that he had some caching misconfigured. And there was caching so that it didn't always be, do the data pulls out of AWS. And the cache was set to say, if it's under 15 gig, cache it. If it's over 15 gig, oh no, don't cache that. Pull it fresh every time. Now, there is a question about why you would ever have a setting like this. Like, who would ever say, please cache my cheap stuff, but my expensive stuff I want you to burn money for? But computers, right? We've all seen settings like this. So it was all a bit stupid and embarrassing. And so I said that the fact that you had to run in really small instances and normal size instances was the chaos part. But actually, I think maybe trying to keep hold of the costs is the chaos part. We see some strangenesses with releasing as well. When I joined IBM, we sent hardware out on physical disks. And they got pressed in Ireland, and we only did it once every few years, because it sounds expensive to do that, and it was expensive. So we would have a release schedule, and we would stick to that release schedule, and if your feature didn't make it, it didn't make it. Now, of course, with microservices, we can release way more often, which is great. But we don't always actually do that. Often, the business hasn't caught up to those aspects of what microservices enable. When I was in the IBM garage, we had a conversation with a large bank, and they were getting their lunch eaten by the challenger banks, and they looked and they said, the reason we're losing is because we're moving too slowly. The reason we're moving too slowly is because we have this huge COBOL estate. We should change it to microservices. And so at this point, the team were going, oh, yes, we can help you with that. We can help you migrate to microservices. But then they added, our release board only meets twice a year. And at that point, we kind of went, because we knew it didn't matter how many microservices they had, until they changed that release board cadence, they were going to release all of their microservices in a big batch every 6 months at best. And so they were going to take all the overhead of microservices without the benefit. And they probably should have just written a Java monolith. And when we talk about microservices, our goal is modularity, but of course modularity has always been a goal of computer systems, and there's lots of ways to achieve it. And so when we talk about microservices, so often when I was a consultant, we would sort of start the conversation and they'd say, yeah, we want to go to microservices. Well, why do you want to go to microservices? Because we want to go to microservices. But microservices, they're not a goal. When you write your thing of like, what do we want to do? Microservices shouldn't be the what, it should be the how. And often when we would talk to people about, well, why do you want to do microservices? They would say, because Netflix is doing it. It's like, well, that's not a really good basis for architectural decisions. And sometimes they would say, well, we want to do microservices because we want to use the cloud. And it's like, well, you can use the cloud without using microservices. Cloud and microservices are not synonyms. Even cloud native and microservices are not synonyms. You can be very cloud native without using microservices. And there are good reasons not to use microservices, or at least there are very good reasons to be careful about microservices and to be aware of some of the things that may go wrong when you use microservices. Did any of you see Jennifer's talk yesterday about the challenges of micro front ends? Yeah, it was. I loved that talk because I have sort of some similar talks, and we see these challenges over and over again, that we sort of have this dream of we're going to go to micro and everything's going to be amazing. It's like, well, no, you need to fix the other problems too. So my first microservices project, I was sort of parachuted in to try and rescue it, and I arrived, and they said, every time we touch one microservice, all of the others break. Now, if you've been paying attention, you know that this isn't supposed to happen with microservices. Microservices, they're supposed to be independent. But just because you're distributed doesn't mean you're decoupled. It just means that you have a distributed monolith rather than on one process monolith. And so then that means that all the things that you used to get, like compile time checking from your IDE, or guaranteed function execution, so that you were in the same process when you told the thing to do the thing, it did the thing. Now you lose those. And then you get this sort of creeping spaghettification. And it's not just normal spaghetti, it's spaghetti over the network. And if there's one thing you do not want, it is spaghetti over the network. And so when I looked in to try and figure out what was going on, I saw that they had a problem with their domain divisions. And they had a sort of a domain model. And it was quite a complex one. So there was about 20 classes and then about 70 fields on some of the classes. And they didn't want to be coupled. So they denormalized and they cut and pasted that same class into every instance. But it doesn't quite give you the outcome you hope for. So the ideal with microservices is that you have all your little services, and then your domain model, each microservice maps exactly to one domain. What had happened in this instance was the domain was exactly common across every microservice, which was bad. And it meant that it was incredibly, incredibly coupled. And I think that probably the solution is that they shouldn't have had microservices at all, or they should have accepted the coupling and done something to manage it. So the moral of the story is that even though they both start with D, being distributed is definitely not the same as being decoupled. And we have all sorts of problems when we talk to a service, because sometimes the service doesn't do what we were expecting. The semantics are different. Sometimes the service doesn't even have the same syntax that we were expecting. And this is one of the things that happened in that bad project, was every time someone would correct a typo somewhere, they wouldn't realize that it needed to ripple out through the whole rest of the system because they were decoupled, and everything would fall over. So if you're going to do microservices, you've got to get really, really good at releasing, you've got to get really good at automation, and you've got to get really good at testing. But testing is something else that has actually changed recently. So for a while, we've been talking about this idea of the test pyramid. And so at the top are your end-to-end tests. They're at the top because they're really useful, but you shouldn't have very many of them because they're very expensive to write and expensive to run. At the bottom, you have your unit tests. Those are really cheap to write, cheap to run, but unfortunately, they don't give you a whole lot of confidence that your system actually works. In the middle, sometimes you have integration tests in the middle, but what I would recommend having in the middle is contract tests. And this is something that Jennifer talked about yesterday as well. Because contract tests give you a lot of the confidence of end-to-end tests, but with the cost of unit tests, which is a pretty good deal. And there's a nice way of thinking about how contract tests work by comparing to a fire alarm, which I hadn't even thought about it until I got to this slide, but I wish I could say I did it all on purpose. So there's a whole bunch of ways that I do not recommend testing a fire alarm. One of them is in a conference with 900 people while they're in the building. But there's another way that I do not recommend testing a fire alarm, which is to set your house on fire and then stand outside your house going, can I hear the neener, neener, neener? If so, the fire alarm works. Because you have a lot of confidence that the fire alarm worked, but it was a very, very, very expensive way to test the fire alarm. The other way that you can test a fire alarm is, I don't know how many of you are good and do this, but if you look closely at your fire alarm, it will have a little button on it and it says push once a month. So you push that button once a month and it goes, na, 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 na. This gives you a lot of confidence that if you push the button, the fire alarm makes a noise. But fires don't have fingers. A fire is never going to walk into your house and push the button. What you really want is confidence that if there is smoke, your fire alarm goes off. So how many of you have seen one of these? No hands. I did these slides, and then I realized I think I might be the only person who's ever seen these, so then it sort of becomes less good as a metaphor. But sometimes in things like shopping malls, you'll see a little person going round, and they have a long stick, and at the end of the stick is a little cup. And that cup, they sort of wrap it around the fire alarm, and then it sort of goes psst, and sends smoke out, and then the fire alarm goes neenon, neenon. And so then you get the confidence that the fire alarm works. You don't get as much confidence as if you'd set your house on fire, but it's probably a really good compromise. So with contract testing, the idea is very similar. So I was hoping to do a demo, but I have talked too much. So I have 2 minutes for a demo. So I'm going to do the world's quickest demo, but I will share the link to the source code if people would like to see it. There's a bunch of ways you can do contract testing. You can do it based on OpenAPI. That gives you a lot of confidence for the syntax. It gives you a bit less for the semantics. You can do Spring contract testing, but that only works for a single language, and again, it doesn't keep it quite as nicely in sync as you might want. So what I would recommend is packed contract testing. And packed contract testing, the way it works is you have a little JSON contract, and it acts as a mock for the consumer, and it acts as a functional test for the provider. So let me just... Sorry, I'm going to have to change my displays. Cool. So what I've got is I've got the world's simplest microservice, which just has a front end and a back end, and it doesn't actually have anything else. And so I've got a BFF on the front end, and I've got I've got a BFF on the back end, and then I've got a front end. And if I change something on the front end, on the back end, my front end will break. And what the front end can do to protect against that is, let me make that bigger, it can write something called a contract test. And a contract test will look a lot like a functional test. So I'm saying who my provider is, who my consumer is, and then I'm giving some parameters for what kind of answers are acceptable to me. Once I've done that little bit of setup, then I can run my normal tests, test my consumer as I normally would, and it's getting this mock. And as a side effect of running that test, I get a contract like this. So this, the consumer owns the contract, the consumer generates the contract. It can send it up to a broker, a packed broker, or it can check it into the provider's source control. The provider then takes all of its contracts from its various consumers and runs them as part of its validation. So then it knows if it makes a change, it knows if it's breaking the consumer. So everybody gets something out of it. The provider gets free functional tests, and the consumer gets a free mock. So then on the provider side, the test would look something like this. So you can see there's actually basically no test. It's just saying, please run what you find in that JSON contract. Here is where my server is, and then it will just do the thing and give you that test. So basically, consumer-driven testing, contract testing, it can solve a whole bunch of problems in the integration in between services. The packed gives you the mock for the consumer, it gives you the functional test for the provider, and then you've got that shared JSON contract. And with that, I will stop. Thank you very much. And I'll tweet the link to the slides as well, because I couldn't upload them before the talk, because conference Wi-Fi.
Thank you, Holly. Thank you very much. I have a little gift for you.
Oh, thank you.